Hello, lovely people. It's Mr. Ryan, and you are looking at a fisheye lens. This is the best way I can get everything to be zoomed in. Believe me, if you look at it the other way, it's pretty zoomed out. I think that this is gonna be just fine, mostly because I don't want to edit anything, so we're just taking this as is. Welcome to your study guide. We're talking about Unit 2. I'm only going to go over a few questions. This one is going to be based on graphing our vertex form. If we look here, this is definitely in vertex form. We can see that because it has pretty identifiable look to it. It has my parentheses, it has that number in the front, it has my squared on my parentheses, and I have that -1. It looks pretty identical to the general form that we have for vertex form. We can get the vertex verbatim from here. So we can take our 3, positive 3, because we take the opposite of what is inside since that negative was there before us. And then my k value we bring as is, so it's -1. Because our vertex is this, I can go ahead and graph it. I got 3 comma -1, 3 in the x value, -1 in the y value. And then from here, I can either do my distance method or we can do our table method. Either way is fine. Please just choose one to get really good at. If you feel like the table method is for you, that's awesome. If you feel like the distance method is for you, amazing. Just choose one. Our distance method is based off of our vertex. This is positive 3 comma -1. We know that from if we were looking at our parent graph, our parent graph looks like this. And our distance between points is pretty standard. So it's going to be, from our vertex, it's going to be right 1. And then I go up 1 unit usually. That's how we use it in our parent graph. This is 1 comma 1. But for our purposes, when we have anything else happening in our graph that our parent graph does not do, we have our vertical stretch and we multiply that by our a value. Our a value we'll talk about our vertical stretch. So in this case, our a value is -1. I know that because it's right here. Also, this negative means that I'm going to have a graph that is going downward instead of upward. I know that it's going to be reflected on my x-axis. So this vertex point is going to be a maximum point. Since it's a maximum, I don't need the rest of my graph because this is as high as my y values will go. Everything else will be going downward. Going back to my distance method, it is our vertex. We are moving right 1, and then we're moving up 1 unit times our a value. But our a value is negative. That means that I'm going down because negative is a downward movement in our y values. So this is going to be, a is our -1. So I could plug in -1 for our a. And I go down -1. So right 1 and then down 1 is my next point. From this point, I go right 1 and then usually it would be multiplied by 3. And then we're going to multiply our a value of -1. That means I'm going downward, -3. So I'm going to go right and then down 3 units. And then we know that it is symmetrical across my axis of symmetry. So on the other side, it does that. If we look at our table method, we have our x comma y. Our y is our equation, so I have -x minus 3 squared minus 1. And always our vertex goes in the middle. I have 3 comma -1. I have 2 and 1 behind my 3. I have 4 and 5 in front of my 3. And then when I plug in 1, it is 1 minus 3 squared minus 1. So it's negative times whatever's happening to my exponent. My exponent is -2. So I have negative times -2 squared minus 1. PEMDAS tells me that I must do my exponents first. So I have -4 minus 1. I get -5. When I plug in 2 for my x value, that's how I plug in that 2. Squared minus 1. 2 minus 3 is -1. Squared is +1. And then I have a negative in front, so it's -1 minus 1. I got -2. And we know that it is symmetrical across my axis symmetry where my vertex is. So I got -2, -5 on this side. I got 1, -5. Oh, I already have that. 2, -2. Perfect, already have that. I have my vertex. I have 4, -2, and I have 5, -5. I have killed it. We have killed it, my friends. Our distance method is our faster method. But if you feel more comfortable with the table method, that's amazing. But we do have to get good at our distance method. So I'm going to put this in here. So for our distance method, we start with our vertex, h comma k, or if we have a standard form, we have to find it ourselves. So whatever our vertex is. And then we usually go right 1. We always go right 1, and then we go up 1 times our a value. And then from this point, we go right 1 again. That always stays the same. And then we go up 3 times our a value. It goes 3 times our a value. And this will inform, if our a is negative, then we have to go downward. That would be the difference there. If you have any questions, please let me know. You can always email me if you need anything. But this is how you do number 1. Thank you.